Hi, I'm Mr. Hoover, and in this video we're going to talk about problem 6. Radium decays exponentially and its half-life is 1600 years, 1600 years. If A0 represents the initial amount of radium in a sample and AT represents the amount remaining after t years, then this is the function, okay? Find the value of K approximated to 4 significant figures. Find what percentage of the original amount of radium will be remaining after 4,000 years. Okay, well, in this case, we're given the exponential function here. And the first question is find the value of K approximated to 4 significant figures. And we know the half-life will be 1600 years. So A of 1600 will be 1/2 of the initial amount. So after 1600 years, you will have halved the initial amount. This is how we start. So you just plug in the 1600 into this function. This is what you get. You divide by A0. This is what you're left with. Now you have to isolate K. So you use the ln on both sides. And you're going to get minus K times 1600 is equal to ln 1/2. Again, like in the previous exercise, e to the minus K times 1600. Well, e to the what is e to the minus K times 1600? Well, it's just minus K times 1600, but you could have done it like this. Now this will be 1 because e to the what will be e to the will be e. E is just e to the 1, so it will be 1. So you can write minus K times 1600. Okay, now this is what we get. Now we have to divide by minus 1600. When you do that and you type it in, you're going to get 4.332 times 10 to the minus 4, which could be written as 0.00043332. And these are the significant figures, okay? The ones that differ from 0, okay? So we had to work it out to 4 significant figures, and these are the 4 significant figures. So this is the value. Either you write it like this or like this. Oftentimes this is the preferred way to write it for scientists. But well, in this case, it's easy to write it like this too. Now, the last question, find what percentage of the original amount of radium will be remaining after 4,000 years. Well, that shouldn't be too hard. We just plug in 4,000 years. And I'm going to write this number up here now. But well, keep in mind, I'm using the stored value of the calculator, okay? So I'm not going to use this value, I'm using the stored value. So you type this in and you get A0 times 0.1768, which means it's 17 or 0.1768 times A0, which is 17.68% of A0. So that means find what percentage of the original amount of radium will be remaining after 4,000 years. It will be 17.68%. 17.68% of the initial value will be remaining after 4,000 years. I hope it wasn't too difficult. See you on the next